I'm a lead data scientist on the marketing team, here to discuss the loyalty membership program and how to use predictive modeling to increase our revenue potential. The target is to increase our loyalty members' spending habits by using our own in-house data and some third-party customer data to create predictive models using our five-path model approach, with the end goal to achieve increased revenue from within our own loyalty membership program. Some past loyalty member insights: we use the training and test sets of our own in-house data, with Y hat being the household spend for each of these loyalty members. And that data included name, age, estimated home value, store visits, etc. The third-party data consumed consisted of consumer data like ethnicity and computer usage, what things they donated to, their political party, gun ownership, and what magazines that they might subscribe to. Some important notes with regards to household spend, or Y hat, was that some noise was actually added to the amounts for anonymization. So keep that in mind when it comes to error and those kind of KPIs. And some of the third-party variables actually toe the ethics line, like the politics data. It included things like religion, marriage views, union membership, things that our data team just does not really include, and they're outside the bounds of our ethics guidelines. So we excluded them from our inspection. The current loyalty member spending takes this shape here. From the training and test data sets, you can see the average is around $300, and the max ranges from anywhere from $550 to $600. But the key point being that the variation is almost $100 swing in both data sets. So again, very broad range of spending habits within our current loyalty member set already. If we look at total, so we had 15,000 members in the training data set, about 4.5 million total. And the test data set was 5,000. That was about $1.5 million total. So overall, with the 20,000 members that we already had, we're looking at $6 million in revenue. And the goal is to use our model to predict new prospects and to increase this number. After some exploration, we saw a lot of missing data, as I show in the red and purple here. 44 of the original 80 variables that we had, we actually removed just right off the bat because the missingness was so high, around 100% in some cases. The average loyalty customer ethnicity is English, Welsh, or German. They're typically female. They're likely homeowners. Their education is usually bachelor or graduate degree. They either have an apartment or residential property. They're more likely to not have a child. Their occupations were really varied, covered a broad spectrum, and there was a large amount of unknowns in there. Store visits range from 4 to 8 times per year. And net worth had a pretty broad range as well, but the majority were in the $50,000 to $500,000 range. And age was on average 62 years old, with the max being 101. Home value perked our interest, so we plotted home value versus household spend straight from the training data set. As you can see here, the large cluster between $20,000 and $400,000 estimated home value, in a pretty broad range of household spend within that boundary. So average home value was $190,000, and the max being up to $1.5 million. Predictive model development. We used our five-path approach, as I show here, which is a multilinear regression, a KNN, two types of regression trees using different libraries, and a random forest model. And we subjected these 5 models to training and testing on the 15,000 loyalty member set and established the RMSE, MAE, and MAPE. We did the same thing on the test data set, which is an additional 5,000 new members, and conducted the RMSE KPI study. After that was done, we chose one of those models out of the original 5 as the best that we were going to use for predicting household spend from prospect data that we've never seen before, using the key factors that we determined. So some of the background: we used vtreat to clean the data prior to modeling, and we also performed a correlation study on the clean data now that it was all numerical. We wanted to know what appears to influence Y hat, if anything. And I plotted here, this is the post-treated data, estimated home value versus household spend. And if you look at the chart on the left, you can see estimated home value was the highest correlation to Y hat. It was positive but very low, but it told us, hey, there might be something here with estimated home value as well as dwelling size. You can see there were 5 other variables post-treatment that popped up from dwelling size. So we kept that in mind as we went forward. Variable selection, we started off with these variables when we started whittling down what we were going to include in our model. And as we use VTreat, correlation studies, backwards stepwise, and judgment as well, we got it down to 8 key variables that I show here. So path 1, that resulted in a very low R-squared, around 0.3, but it did show that the lowest p-value was the home value, estimated home value, meaning it was the most significant in that model. K&N model, we actually had to go to a tune length of 50 to get to a K of 99 to get optimal RMSE using the bootstrap method, as you can see here on the plot. Path 3 was our first regression tree model using Caret. We had 20 validation folds and resampling length of 5, and it got us, it was essentially our best complexity parameter using RMSE was 0.078, which is right here at the beginning. And the tree looks like this. So if estimated home value is not less than 35, then the largest household spend would be 371. That's what that model gave us. I think a better model would be path 4, which is this using our part, and you can see it's a little bit more complex, but kind of the same story. If estimated home value is not less than 129, then that also yielded our largest household spend of $453. And finally, path 5 was our random forest model, which we used 50 trees, and we established mtry equal to 8 using tunrf, and that was done to reduce out-of-bag error for a random forest, as you can see here. The plot on the right shows the mean decrease accuracy plot, and essentially it goes from high to low, meaning the ones at the top, if you remove those, they have the highest impact on accuracy of your model, and they're the most important variable that out of this list. And again, estimated home value is at the top with dwelling right behind it. So our predictive model selection, again, we use RMSE and MAE as our primary KPIs. And what I show here at the far right is our random forest, which you can see with the training data, RMSE is very, very low, lowest of all of them, and same with MAE. But as soon as you walk over into the validation and test data, you can see that it jumps up to much, much higher error, meaning it's overfitting on the training data for the random forest. The best one that we had out of R5 was the K&N model, which yielded MAE of 75.6 and the lowest RMSE of 99.4. So we chose this model to go forward with. An additional study on MAPE, kind of the same story. 47%. Again, these are not very good values. It's high error. But that being said, it is the lowest of the 5, so we chose it to go forward. When we look at our household spend predictions using our Path 2 K&N model, we took in the data set from marketing with all the new customers. We were originally at 6 million roughly in total revenue, total household spend. If we look at the prospect data outlined here that had 5,992 new customers, our model predicted $1.8 million of household spend total in that group. When we break it down, the average was very close in our model to the existing means, around $300, but it was the max and the mins that were affected the most. Our model was predicting short on the high side and very high on the low side. But keep in mind, I want to make a reminder that the variation was already about $100 in our existing data set. And our prospect data set using our K&N model was about $40. So still high variation, but much lower. And again, we have other factors that are going into this. If you recall, we did show the error was pretty high with using RMSE and MAE already. The in-house data variation was already almost $100. And Y-hat at the beginning, we know that this was anonymized with noise. So I don't know how much it was changed or affected or updated. If it was just a straight, we added $50 to each value, I don't know. So that also might have a pretty significant effect on how accurate our model could be. And it also could be that, Y-hat or household spend, maybe we're not looking at the right factors. Maybe we haven't gathered that data just yet. We have a lot of different variables we inspected, but maybe the right one just isn't there. Or maybe there's some interactions that we haven't, acknowledged or inspected just yet. But overall, our studies did find that the overall top 3 variables would be land value, dwelling unit size, and of course, estimated home value as key predictors for influence on increasing household spend amongst our loyalty customers. So thank you. If there's any questions, please let me know. We've also provided the data file for the predicted household spend for these new customers. Thank you.